सर्कल से वो ओपन करके हाँ बस स्टार्ट ये लाइट बंद कर दीजिए
So, good evening to all of you. Welcome to the live session of this course, Aqueous Corrosion and Control. I think we have almost come to the end of this course. And I suppose you had interesting exposure to corrosion, overall corrosion fundamentals, and starting from thermodynamics of electrochemical corrosion and then the kinetics of electrochemical corrosion. Then we looked at the various forms of corrosion. Most of these forms are very relevant to industrial problems. As I told in the beginning, that the so-called 8 forms of corrosion are more or less a simplified version of 8 forms of corrosion. You can also add more forms of corrosion if you wish to. Okay. And yeah, so you have seen the mechanisms of the 8 forms of corrosion. Then we saw the mechanisms, and then we went on to understanding excuse me, the parameters affecting the various forms of corrosion. Once you understand the mechanisms and the parameters, then it's easy to control the various forms of corrosion. And we also saw how do you carry out various testing methods to evaluate materials against corrosion. So today we'll look at the questions that you have, and I'll be happy to answer any of your questions. So let us start the questions now. I think feel free and be happy to interact and try to understand as best as possible. I think the question is from Mr. Mastram Hatish, right? The question reads as follows: as chromium carbide is stable between 450 and 850 degrees Celsius, then how is it present in alloys used in high temperatures, more than 900 degrees Celsius? Okay, yeah. Well, I think these are certainly not chromium carbides. Okay, the chromium carbides in these alloys, they're not these carbides. Okay, and the phases such as niobium carbide, tantalum carbides, they are the stable ones. The chromium carbide certainly is not the carbides which are stable at that temperature. The chromium carbides would dissolve because the phase diagram tells. Actually, if you plot, let me just try to here. Let me just go to the board. If you just look at the just trying to get the pen from here. I am not getting the pen. Okay, so let's not worry about this one actually. Okay, so if you look at the time temperature transformation diagram for the chromium carbide, right? The time, the temperature, the time transformation diagram, you normally see a C curve, right? Now the C curve tells you what is the temperature at which they are stable. Of course, the stability of the carbide depends also on the carbon content, right? When the carbon content is increased, the carbide becomes more stable. As the carbon content is lowered, okay, you find that the carbide becomes stable because the activity of carbon is also reduced. Of course, one of the reasons why this high temperature stainless steels would be having carbides would be the carbon content would be significantly higher. When the carbon content is higher, then it is the carbides are also reasonably stable. The other question is the same person, what are the tests that can be done to analyze failed 316L? I think heat exchanger tubes due to CLSCC. It's a chloride SCC you're talking about, I suppose, right? Yeah. So when you say chloride SCC, now, well, I think you know see, all this failure analysis, it starts from the understanding the basics and fundamentals, right? You can start looking at the investigation. The investigation is in fact is the highest form of the science. It's not that one can start analyzing failures without understanding the basics. That's not really possible. Unless you look at do's and don'ts, if you have a table of do's and don'ts and try to match it, it can happen. So in my view, the failure analysis is not something, very simple as compared to understanding the science of it. It goes at higher level. Okay, coming back to the question. How do you look at the chloride stress corrosion cracking? Now, the definition of stress corrosion cracking is simple, right? You have to have tensile stresses, be it residual or applied stresses, okay? And suppose you have chlorides, again we know from our understanding that the temperature is equally important and the chloride content is equally important. Now, this is one part of it. The second part of it, the stress corrosion cracking also has a characteristics. What are the characteristics of SCC? The characteristics is that it is, I would say, branching cracks, right? You have branches of cracks, right? You have that actually. So we have a branching of cracks that is happening in the material, okay? And the branching crack is one of the things. So you look for the patterns of branching cracks. The other important characteristics of SCC, stress corrosion cracking, is that it's a brittle fracture. So look at the fracture surface and see whether it's brittle or not. If the fracture is quite flat, right, it's something like take a knife and cutting through a butter, for example, you see a nice planar crack taking place. On the other hand, you take a say nylon wire and pull it out. This braided tray on nylon wires. You just pull it out. You see that lot of ups and downs. You have micro wide coalescence if it is a mechanical failure. So again, yeah, of course, it is 316L. Automatically, of course, you are not going to have sensitization. So it's not going to be intragranular stress corrosion cracking. It's going to be mostly transgranular cracking. So when you're looking at the cracked surfaces in a microscope, and you'll see that what kind of macro cracks are looking like. Are they transgranular or is it intragranular cracks? Whatever kind of thing that's happening at all. So it's intragranular cracks, it means it's sensitized, right? If it's a transgranular crack, it is not sensitized. So if it's a transgranular cracks, it's 316L stainless steel, it is failing. that means the material is maybe inadequate, or of course then you got to go back and find out why does it happen. This happen because the temperature has gone up, or the stresses, a lot of more stresses than that is expected to happen. So all this are all these are the things you start looking at. Again, when you talk about stress corrosion cracking, suppose it's HP heater, right? Suppose your boiler, there is a HP heater, high pressure heater, then what happens? Then the chloride content is, the tolerable level of chloride content is so small, right? You can't even have a ppm level chlorides. The oxygen content is very small, the pH is controlled, all this. But in a cooling water system, the allowable chlorides are more, but the temperature is lower actually there. So you need to look at the context in which these failures have taken place and see how the remedial action can be taken. For example, in HP heater, you will never recommend a duplex ender steels, right? Because duplex ender steels at that temperature is not stable, right? You'll have a delta phases and sigma phases can be formed in this one. Sigma phases will form in this. Whereas in cooling water system is not a problem, so you go to duplex ender steel and add them. Well, is there any forum for discuss industrial problems from experts? Well, I think there are various blogs are available. I think if you are a NACE member, there are blogs available actually. There is, I think, Material Testing Institute, I think, right? There is also, if you are a member of that particular organization, I know that, you can get involved in that actually, you can get involved and people ask questions. A lot of people give the answers actually. And unfortunately, I don't blog too much. Okay, but then I don't know. I know that the NACE is one forum. People use that actually. Okay, and so there are blogs that are available, and there is also there's one more. I don't exactly recall. See, there's one more India corrosion forum or something. Okay. The guy is located now in I think Malaysia actually, and he has created a blog, I think, right, when people exchange these informations. Yeah, there are something. Maybe if you Google around, I think you may get more information on that. Are there any other questions? Any of you have? No other questions? Anyone? So if there are not many questions around, I think, should we now close the program, live sessions, or of course you guys have my email ID, and you can always contact me through offline, and my email ID you'll get from the NPTEL website, right? And or you can note down my email ID is VS Raja, that is V for Victory, S for Singapore, RAJA, Raja @iitb.ac.in. Yeah, if there are no questions, we can close. Or huh? Stop, isn't it? Because I don't see that there are any more questions are there. Where is the pen here? The pen has gone.
So you can use my mouse, sir. That's a good for you, sir.
Where is the marker here?
In your mouse, sir.
No, this is the pen, na?
Yes, sir.
How does it go on?
Sir, you can see here, sir.
No, you are not.
Sir, 1 minute, sir. Yes, sir. Then some 1 minute.
Okay, anyway, there's not many things. You can just, yeah. You can do that, okay? You can close today's meeting. So it's not coming, huh? It's not live. I can't write there directly.
Now you are live, sir.
No. I don't know.
Okay. Stop.
Yeah, stop.